So my name is Richard Ellis. I'm the head of the BRC Immune Monitoring Core Facility. It's an immune monitoring core facility, but our informal title is the Flow Cytometry Core Facility, and that really is the aspect of the work that we tend to be doing. Immune monitoring means that we're looking at the functions of different types of immune cells, and the technology that we use to do that is flow cytometry. So there's slightly different aspects to it. We're mostly looking at immune cells, but we don't have to. There are other projects going on here as well, other cell types that we look at as well. And also, we don't just do flow cytometry, we have some accessory technologies as well. So built into that, we do some imaging, which is when we're looking at cells using different types of machines. We might use a microscope and other things as well. So the Immune Monitoring Core Facility really brings together a lot of different research projects from across King's College London and from the NHS Trust as well. And these people come in, they want to analyse cells to find out what the cells are doing, what they're doing in the body. They build up research projects around that, and then they want to analyse that as well. So we want to find out from patient groups, control groups, whether things are different in there. And we're looking at different cell types, and there's a huge variety of different cell types within the body, and each of those cells can be doing different things. And we can use our machines to look at markers of those cells to see what differentiates one cell from another, how they do different things. And there's a wide variety of different markers that we can use these machines to look at. And the different markers can really span many different types of disease and health, many different aspects of them. So we fit into the larger clinical trial process by being right at the front end, where a lot of people come in and develop research questions. We have basic research needs here. People come in to run cells on our analyzers to find out interesting things about them, to find out new theories about cells. And then it goes on to build into the whole process. So maybe we can actually find some markers on the cells which really help us to define a particular disease characteristic. Maybe we can turn it into a diagnostic tool, a kit that can be used, for example. And then people can come back later in the research process, once they've recruited patients, they've got a clinical trial underway to test if this is really valid in a group of patients. Maybe we've seen it in a model, we've seen it in a limited set of cells that people examine in the lab. Let's roll it out into patients. When people come back with those patient studies, or when researchers come back with those patient studies, what they want to look at is to see if there are differences in there. We can use our same instruments in those processes to look at the different types of things that are going on and see if the patients really are different. And then once that's been done, go to the next stage of the clinical process, which is to roll that out to a larger scale, and then it goes to a diagnostic laboratory. So we've created a kit or a technique which is easy enough to be run in a diagnostic laboratory. So it takes them right from basic research, be involved in different steps in that pipeline, and come back at the end. There are other different techniques that we can use, for example. So these machines will analyse cells. We have other machines which can sort the cells, to purify cells. So we can take cells from a sample and actually purify different types of cells from that and give the researchers back individual pure populations of cells. They can then use those to study different things. They can put those cells into culture, they can grow them and expand them and test them for different things and see what those cells do under different conditions. So with different types of equipment, we can also be involved in different steps of the process as well. The best part of my job is really interacting with many different users. One of the things that's really exciting in a job like this is I don't know who's going to come through the door on a given day and what interesting experiments they're going to come up with. But one thing that I can say for certain is we have hundreds, literally hundreds of users that will all come in with different research needs. As someone who used to do research myself, so I had a career in research before running facilities, this is something that now I'm not just involved in one project. I used to work with diabetes. Now I'm involved in many different projects, and that's really exciting to see all the different things that are going on, so the breadth of research. And in a large place like this, we have so many things going on. There's always something interesting to see. So clinical research offers us an opportunity to see into different aspects that we wouldn't normally get to see into when we're working in basic research. And working with patients actually gives us a real clear end goal of where we want to take things. So that's really exciting for us. We can actually be on a floor with patients. We can see how we can contribute to their processes. So it's really a valuable thing for us to be able to have some goal to work towards there. And that's something that we get out of working with clinical samples as well.